All right, so what we're using is we're still using the power rule. We're still using our constant rule. So this is the constant multiple rule. All right, I'm going to go with the chalkboard because I like old school. And A, we have y is equal to 2 over x squared. All right, the problem is that kind of gives me some issues with how to do this problem. So that's really like 2 over 1 times x to the negative 2 power. All right, and now that I have that, I am able to use the power rule. Okay, so the power rule told us that for any kind of x to the n, all right, the derivative of that, or y prime or f prime, is equal to n times x to the n minus 1. So you just take the exponent, bring it down and multiply by whatever's in front of the x, and then you reduce the exponent by one value. Okay? So in this case, all right, we have our exponents negative 2. Negative 2 times 2, because it was in front of that, times our x, you got negative 2 minus 1.
Wait a minute.
Right? So that's negative 4x to the negative third power.
Okay, I don't know that. Wait a minute. Where the other two come from?
Example B. So example B says 4 over 3 x to the third. Okay, so I can really treat this 4 over 3 like I can pull the constant out front. Okay, so any number you can pull out front. So that 4x to the third over 3 is like 4 over 3 times that. So if I take the derivative of this, y prime, okay, remember that prime means the derivative of. All right, you're going to leave your 4 over 3 in there. Okay, bring my exponent down, so 3 times my 4 over 3 x. All right, and then I take 3 minus 1. Okay, so y prime is actually, the 3's cancel. I have 4x to the second power. Did you still get 4x squared? Then that's fine. Okay? Now, part C says S of t is equal to negative t to the fifth power. So I'm going to use my rules. All right, Kayla, what are you thinking right here?
Okay, so it's like basically having 1, so you got negative 1 t to the fifth.
Yep.
And you do 5 times 1 will be negative 5. So I subtract 1, so you'll get negative 5 t to the fourth.
Perfect. So the derivative is negative 5 t to the fourth. Look at part 4. Okay, y is equal to 4 times the square root of x. Okay, remember what the square root of x actually is. So that's really like 4 times x to the 1/2 power. Okay, so if I'm using my rule, bring that exponent down and multiply. So 1/2 times 4. All right, x to the, you got 1/2 minus 1. And that's where it gets a little bit tricky. Y'all have to go back to elementary school and remember how to subtract integers. All right, so some fractions. If you take 1/2 minus 1, you get negative 1/2. So this is 4 over 2 is just 2. Okay, and this is x to the negative 1/2 because 1/2 minus 1 is negative 1/2. Okay, now x to the negative 1/2, we don't like to write stuff with negative exponents. So we need to make that a positive exponent. So you could say 2 over x to the 1/2, or you could just write it as the square root of x. Either way, doesn't matter. Saw some awesome stuff walking around. Y'all seem to kind of be getting the hang of it. It's just one of the things you got to practice as you go. So look at, what do we say? E was the next one. What y'all get on E for 5 over 3x to the third? So a lot of y'all got that. Negative 5x to the negative 4. Okay, if we don't want to use negative exponents, we need to take that x to the fourth and put it in bottom. Okay?
So does it matter?
So really, like on a test, they're going to want you to write it like this. Honestly, guys, sometimes the stuff that we're going to do, there's some intense, like there's a lot of algebra that needs to be involved. And as long as you get the calculus parts of it, like that's kind of what I'm really looking for, is to know the calculus. That's what the AP test is looking for, if you know the calculus. So sometimes they don't make you simplify stuff all the way down if they know what you're talking about. They assume that you know the algebra behind it. All right, let's look at F. So we said this was really like negative 5 over, we said what, 27 x to the third? And that's really like x to the negative third. So what did y'all get? I saw like some people did 15. I saw some people do 15 over 27 because 5 times 3. And then x to the negative 4. Okay, you could also do like negative 3 times negative 5 over 27 and simplify that. Right? And that would be 9. Well, the 9 wouldn't have to be in the bottom. Yeah, the 9 is in the denominator right there.
Oh, so it'd be negative 5 over 9.
Positive 5 over 9. X to the negative 4. Which again, you could leave it like that, or you could say, hey, we don't want negative exponents, so 9x to the 4th. Okay? Let's talk about G. So S of t equals, do y'all agree with this? This is t to the negative 1/2 power. Okay? So now let's use our power rule. So if I bring negative 1/2 down, multiply by 40, t to the negative 1/2 minus 1. So let's go back. You got to remember fractions right here. Okay, this part becomes negative 20. Okay, t to the what? So you got to think about that. That's negative 1.5. Or, here we go, minus 1, that's really 2 over 2, right? So negative 1 minus 2, that's negative 3 over 2. So that's really negative 3 over 2. Okay? So if we want that as positive exponents, put it in the bottom. 3 over 2. You could also write that, all right? Wouldn't have to do this like this. You could also write this as this. These are equivalent. All right? Those are the same, square root. All right, let's look at H. So you have 12. I'm going to rewrite this as a negative exponent. So this is x to the negative 3 over 5. Okay? So again, now that I have it like that, I can use my rules. Yes, sorry, it is 5 over 3. Yeah, 5 over 3. Because the thing outside of the radical is what goes in the bottom of the fraction. Okay? So now we're going to use our power rule. So this is negative 5 over 3 times 12 times you got x to the negative 5 over 3 minus 1, which is like saying minus 3 over 3. Because 1 is 3 over 3. Always go ahead and change mine to be like that. So what is that? That goes to 4, right? So that's negative 20.
What's on the phone? Oh.
Negative 8 over 3. And that would be negative 20 over what? Cubed root of x to the 8th power.
Okay, so Miss Lisa, if I did 5 divided by 3, got 1.6666667, and I just multiplied by 12 and got 20 instead of.
That's fine.
What you just did.
That's fine. You can do it both ways. As long as y'all are getting that, I don't care how you get it. Okay? Let's look at, on part 5, let's look at C together. All right, you have 2x minus 3 squared. So there is a rule for this that will make it a lot easier for us. But right now we don't know that rule yet. Okay, you're going to get it on my video tomorrow. So right here we need to FOIL this out. Okay, so we got to go ahead and FOIL this problem. All right, so what this means is think about what exponents mean. All right, let's try to reel it back in right here. Okay, 2x minus 3 times 2x minus 3. So if I FOIL this out, I'm going to create a polynomial. All right, that helps me out here. Big word, polynomial. 2x times 2x. 4x squared minus 6x minus another 6x plus 9, right? So this is really 4x squared minus 12x plus 9, okay? So now, that is f of x or y or whatever, okay? We're trying to find the derivative. So if I want the derivative, that's that little prime up there. Remember, you can do this in pieces. So what's the derivative of the first part? 2 times 4, right? Which is 8. X to the 2 minus 1, so x to the first. So it's just 8x. All right. Minus, you got x to the first there. 1 times 12 is just 12. Okay, x to the 1 minus 0, so the x goes away. All right, and then your constant doesn't work. Yeah, so derivative of a constant is always 0. So this is just 8x minus 12. Okay. Now, something cool to notice that you're gonna see later in the chapter, but something cool to notice is your original function is a quadratic. See how it's quadratic? X squared. And my derivative is linear. 8x minus 12, that's a linear graph. Okay, so that's kind of something that we'll look at graphs more on the computer. Y'all ready? Riff part E? Let's go. Come on, E, I like it. Here we go. F of x, 6 square root of x times 2 square root of x minus 3. Okay, so what we need to do, all right, is we need to distribute. We need to distribute. So I'm going to take 6 square root of x times 2 square root of x. Okay, so that's 12. Well, it's square root of x squared.
Oh, you just get the
So it's just x. Okay. Y'all overthink everything. Y'all need to just relax. Okay. Now, 6 times square root of x times negative 3 is negative 18 square root of x. So that's really what f of x looks like in simpler terms.
Is that derivative though?
All right, we haven't gotten to the derivative yet. I'm going to rewrite f of x again to help us out because I want to write it with powers because we're going to use the power rule. So that's really x to the 1/2 power right there.
Right. Oh.
So now we're going to use our power rule. Okay, and we're going to go through and do this one and get the derivative of this.
I'm doing this.
So